Imagine you're sitting by a fire and the flames are dancing in front of you, casting dancing shadows across the faces of people you've known your whole life. Maybe 25 of them clustered around this small circle of warmth and light, and it's 74,000 years ago in a place we would someday call East Africa. But you don't know that name, you don't know your world is Africa, or that there are continents and oceans beyond the horizon, because your entire reality is this moment, this fire, the smell of meat roasting on stones, the sound of children laughing, the feeling of safety that comes from being surrounded by your people in the darkness, and above you, the night sky stretches out in a way that would terrify any modern person. A sky so full of stars it almost hurts to look at it. A sky that holds perhaps 10,000 visible points of light, and you and your people are looking up at those stars, maybe wondering what they are, maybe telling stories about them, maybe seeing patterns and creatures in their arrangement, and you feel small but not insignificant because in this moment, around this fire, you are the world, your band is civilization, your knowledge is everything that matters, and you have no idea whatsoever that on the other side of the planet, in a place you could never reach even if you walked in a straight line for a year, on an island called Sumatra that sits like a spine down the back of Southeast Asia, something is happening that will change everything. Something that is building pressure in the dark beneath the earth. Something that in just a few years will rewrite the human story so completely that most of what science has taught us about how we survived on this planet will need to be rewritten, because at this very moment, at this exact moment in history, the single largest explosive force that has occurred anywhere on Earth in the last 2 million years is preparing itself, gathering its strength, waiting to be unleashed. And when it comes, almost everything will change, and you won't understand why your hunting routes are shifting, why the animals are acting strangely, why the sun seems dimmer even in the middle of the day, why your children are becoming more rare because the world will have entered something that scientists will someday call a genetic bottleneck, an hourglass through which humanity will have to pass, and on the other side of that hourglass, the people who are your descendants, and my descendants, and everyone's descendants, will all carry a mark of this moment in their very DNA, because when the Toba supervolcano erupts, it will nearly kill everything alive on Earth, including almost every single human being, and that near-extinction will leave such a small population of survivors that every single person alive today is descended from maybe just a few thousand humans, maybe fewer. So in a very real sense, you and everyone you know and everyone who will ever be born in the future is right now sitting at the edge of the most important moment in human history, even though you have absolutely no way of knowing it. Let me take you back even further first, back to this world before the eruption, back to 74,000 years ago, to understand what it means to be human at this moment in time, because humans like you have existed for about 200,000 years, and that might sound like an enormously long time, and it is from the perspective of your life or my life. But from the perspective of the Earth or the universe, 200,000 years is barely the blink of an eye. It's a single day in a year-long calendar of human existence. And yet in those 200,000 years, your species has done something no other animal on Earth has ever done. You've developed language, full language, not just grunts and signals, but words that can describe abstract concepts and the past and the future. You've developed art, creating paintings and sculptures and carvings that express something about your inner experience, something beautiful that serves no survival purpose. And yet you do it anyway. You have tools, not just simple rocks that happen to break a certain way, but carefully crafted stone tools designed for specific purposes, with handles and edges and blades that require planning and knowledge passed down from one person to another. And you have fire, which might be the single most important thing your species has ever controlled, because fire lets you survive in places no primate could ever survive before. It cooks your food so your stomach can absorb more nutrients. It keeps you warm. It lets you see in the darkness. It lets you gather around it and tell stories and pass knowledge to your children. And fire is so important to your existence that you build your homes around it. Your entire social structure revolves around the fire, and you have something else too, something that separates you from every other human species that's ever existed. You bury your dead, and you bury them carefully, sometimes with flowers, sometimes with tools and ornaments, and this means you understand death in a way no other animal does. You understand that something about a person continues after their body stops working, whether that's a spirit or a soul, or something you don't even have a word for, but you understand it. And this is also the moment in human history when language becomes sophisticated enough that you can tell myths and stories, and your stories are probably already explaining where humans come from and why you exist and what happens after you die, and these stories are probably pretty sophisticated and probably involve spiritual beliefs and ideas about the relationship between humans and animals and the land and the sky. So when I say you are fully modern humans, I mean it. Your brain is identical to mine. Your capacity for language and creativity and abstract thought is identical to mine. You would be just as capable of learning to read and write and do mathematics as any child alive today, except you've never had the opportunity because those technologies won't exist for thousands of years, and your population is very small, maybe 100,000 humans total on the entire planet, spread across Africa primarily, with maybe small populations beginning to venture out to the Middle East and other parts of Eurasia, and you have no idea how small you are, no way of knowing that you are a rare species on a rare planet. You just know that there are people you know and people you've heard of from other bands, and there are probably people you've heard myths about who are legendary or dangerous or distant, and that comprises your entire understanding of human civilization. And life is not easy. Life is hunting and gathering. It's finding plant foods and hunting animals, sometimes successfully and sometimes going hungry. It's dealing with predators and parasites and infections. It's infant mortality that would shock any modern person. It's a life expectancy that might reach 50 or 60 if you're very lucky, but is probably closer to 30 or 40, and yet your culture is rich, your relationships are deep, your understanding of your local environment is encyclopedic. You know every plant that grows within 100 miles. You know the behavior of every animal. You know where water is in the driest season. You know constellations and seasons and how to predict the movements of animals and where they go to breed and die. And this knowledge is precious, and it's passed down through stories and through teaching, from grandmother to grandchild, from master hunter to apprentice, and your society is probably fairly egalitarian, with no kings or empires, though maybe some individuals are respected more than others because they're better hunters, or have more knowledge or are older and have seen more things. And this is the world that exists at this moment, fragile and beautiful and ancient in its own way, even though it's actually the very beginning of human civilization, and then everything changes. Because on Sumatra, beneath a place called the Toba caldera, something catastrophic is about to happen. Let me take you inside the earth now, beneath the surface of Sumatra, down through the crust, down through layers of rock that have been pushed and crushed and heated for millions of years, down to the magma chambers beneath Toba, and what you would see if you could survive that journey is a space, an enormous space, bigger than any city, maybe the size of a small country, filled with molten rock, with magma so hot it would vaporize water instantly, and this magma chamber has been filling up slowly, very slowly for hundreds of thousands of years, as the Indo-Australian plate subducts beneath the Eurasian plate, pushing deeper and deeper into the earth, and as it goes deeper, it gets hotter, and as it gets hotter, the rock around it melts, and the molten rock wants to go up, wants to escape back to the surface, and it's been collecting in this chamber, and the pressure has been building and building, like a balloon being filled with air. More and more air, pump after pump after pump, and the balloon is getting tighter and tighter, and eventually the pressure becomes so great that it has to go somewhere. It has to find a way out, and so it starts pushing upward through the crust, finding cracks, widening them, pushing against the rock above it, and the rock above is solid and thick. It's been sitting there for millions of years, but it can't hold back this pressure forever, and the pressure is growing, and the rock is cracking, and inside the cracking rock as it starts to break apart, gases are being released, volcanic gases that have been dissolved in the magma, and these gases are building up pressure too, and the whole system is like a kettle of water that's been heating up for a very long time, and now it's about to boil, and about 74,000 years ago it boils, and when it boils, it doesn't just boil in a small way, it doesn't just leak out slowly or build up pressure gradually over many more years. It happens, it finally happens. The rock above breaks, the pressure releases, the magma and the gases start racing toward the surface, pushing through the crust, and as they go up, more magma is pulled up after them, and more, because now that there's a pathway, the whole system is releasing, and at the surface, on the island of Sumatra, the ground begins to shake. At first, maybe just small tremors, just the kind of thing that you might notice if you were sensitive to the earth. If you were an animal with a keen sense of vibrations, and the animals are sensitive, the animals feel it first, long before any human would, and they're panicking, they're running, birds are flying away, insects are leaving, predators are running toward the coast or up into the hills, prey animals are following them, and then the shaking gets worse, much worse. And it's not just shaking now, it's violent. It's the kind of shaking that knocks things over, that breaks trees, that scares every living thing into panic. And the ground itself is starting to shift and crack. And if there were any humans on Sumatra during this time, which there probably are because Sumatra is warm and has lots of food and water, they would see the sky beginning to change. They would see ash beginning to fall from the sky, just a light dusting at first, like snow but grey and hot, and the sun would start to dim because the air is beginning to fill with particles, with tiny bits of rock and ash that are being ejected from the volcano, and then the main eruption begins. And when the Toba supervolcano erupts, it's the largest volcanic eruption in the last 2 million years. It's perhaps the largest eruption in the last 70 million years. And to give you some perspective on how powerful this is, Mount St. Helens erupted in the United States in 1980, and it killed 57 people. It flattened thousands of square miles of forest. It ejected about 550 million tons of material into the atmosphere, and it was a VEI5 eruption, which on the Volcanic Explosivity Index is quite powerful, but Toba is a VEI8, which is the maximum on the scale, and it's not just a little bit more powerful than Mount St. Helens, it's exponentially more powerful, it's roughly 3,000 times more powerful. Toba ejects 2,800 cubic kilometers of material into the atmosphere. And to help you understand what that number means, imagine the largest building in the world. Imagine a cube of rock and ash and pumice and pyroclastic material that is so enormous that if you stacked it, it would be bigger than a country. And all of that is being ejected into the air in a matter of hours, and the eruption column rises up, 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 25 miles straight up into the sky, right through the troposphere, into the stratosphere. It rises so high that it's visible from incredible distances, and the sound of this eruption is the loudest sound that nature can produce on Earth. It's so loud that it's heard across the entire planet. And when I say heard, I mean people thousands of miles away, in Africa, in Europe, in Asia, in Australia. People living their lives have their ears suddenly filled with a sound like rolling thunder that just never stops, and they have no idea what it is. They've never heard anything like it, and this sound is terrifying to them. And then things start happening that are even more terrifying, because Toba isn't just ejecting material into the atmosphere, it's also creating pyroclastic flows, which are avalanches of superheated ash and gas and rock that move across the landscape at hurricane speeds, at speeds of over 100 miles per hour. And these pyroclastic flows are hot enough to incinerate anything they touch. They're hot enough to burn stone, hot enough to turn people to ash instantly, and within 100 miles of the volcano everything is incinerated. Everything alive is burned to death, and this zone of destruction covers an area bigger than many modern countries, and the ash cloud is moving outward too, spreading across the region and then across the continent. And the ash is so thick and so voluminous that it blots out the sun, and day becomes night, complete blackness, and the temperature drops because the sun's light is being blocked by trillions of tons of ash particles, and then the ash begins to fall. It begins to rain down from the sky like a grey snow, and it covers everything. It covers the ground, it piles up like drifts, and people who are not killed by the pyroclastic flows or the bombs ejected from the volcano are suffocating in the ash. They can't see, they can't breathe, they're probably panicking. They're probably running in random directions, trying to find shelter, trying to find water, trying to find other people, and many of them die, simply from breathing the ash, from having their lungs filled with volcanic particles. And the ash is so thick that even thousands of miles away, the sky is darkened, the sun is obscured, the light becomes like twilight, like the sun is behind a giant cloud that never moves, and temperatures are dropping everywhere, because the ash in the upper atmosphere is reflecting sunlight back into space. And without that sunlight, the Earth begins to cool, and it cools rapidly, not gradually, but in a way that would be noticeable if you were alive at that time. And this is happening to your world, to the world of the humans sitting around fires in Africa and across Eurasia. And they don't understand what's happening. They don't know that a volcano has erupted because they've never even heard of a supervolcano. They don't know what volcanoes are, they just know that the sun is getting dimmer, that it's getting colder, that the world is changing in terrifying ways, and the animals are changing too. The animals are confused, they're migrating in strange directions. Some of them are dying because their food sources are disappearing, because plants are dying without sufficient sunlight, Because the world is becoming darker and colder and stranger than it's ever been in living memory, or in the memory of anyone's grandparents or great-grandparents. The eruption itself takes maybe 8 hours from start to finish, but those 8 hours reshape the planet, and when it's over, the island of Sumatra is forever changed. The volcano has collapsed inward on itself, creating a massive caldera, a giant bowl-shaped depression in the ground that's over 60 miles across and 3,000 feet deep. And this caldera will fill with water over thousands of years to become a lake, one of the largest and deepest lakes in the world, and it will sit there as a reminder of what happened, a scar on the landscape that will persist for as long as humans exist. But in those first hours and days after the eruption, the sky above the entire planet is filling with ash, with aerosol particles that are so small they stay suspended in the upper atmosphere for years, and these particles are spreading around the world, travelling on the winds, blocking out the sun, and the effect is immediate, within days. The sun is noticeably dimmer across large parts of the world. Within weeks, the entire planet is affected, and this is called volcanic winter, and it's something that scientists have modelled and studied, and what they've found is terrifying. The temperature drops. It drops immediately, not gradually, but in a sudden shock that would be catastrophic for any ecosystem that wasn't prepared for it, and humans are not prepared for it. Because this has never happened before in human history. There's no genetic memory of this. There's no myth or story that tells you how to survive this, because no living human has ever experienced anything remotely like it. The sky becomes a perpetual twilight. The sun is visible, but it's like looking at the sun through thick clouds all the time, and the light is strange and eerie, and plants start to die because they don't have enough light to photosynthesize, and as the plants die, the herbivores that eat them start to starve. And as the herbivores starve, the carnivores that hunt them start to starve too, and the entire food chain is collapsing under the weight of this environmental catastrophe, and humans, who are at the top of the food chain, are suddenly facing starvation too. Not because food is gone completely, but because it's become so scarce that finding enough to eat becomes the entire focus of existence. And remember, these are people who live from day to day, season to season. They don't have stored grains in warehouses. They don't have livestock that they're raising. They have what they can hunt and what they can gather, and suddenly both of those sources are drying up. The animals they hunt are leaving, migrating to places that still have food, or dying of starvation themselves, and the plants are withering and dying where they stand, and humans start to make difficult choices about how to survive. They might stay in one place hoping that things will improve, or they might start to move, searching for places where the ecological collapse hasn't been quite as severe. And some of them will find those places. Some of them will migrate to areas that are less affected by the volcanic winter. Maybe near the equator where there's still enough heat to keep some food sources alive, or maybe inland where the ash didn't fall quite as thickly. And some humans will survive by being in the right place at the right time, by being lucky, by having the knowledge and the strength to adapt to these new, terrifying conditions. But many won't survive, many will starve, many will die from exposure to the cold as temperatures drop. The global temperature probably drops between 5 and 10 degrees Celsius, and while that might not sound like much, it's catastrophic. It's the difference between a climate that's survivable and a climate that's barely survivable. It's the difference between finding enough food and slowly starving, and this cooling lasts for years, maybe 6 years of volcanic winter, 6 years of dim sun and cold and dying plants and dying animals, and human population starts to collapse. And we can see evidence of this in the genetic record, because all humans alive today are descended from the humans who survived this bottleneck, and when genetic scientists have studied human DNA, they've found markers that suggest that the human population at this time was reduced to perhaps just a few thousand individuals, maybe as few as 1,500 breeding pairs, some scientists think, which means that you, sitting by the fire 74,000 years ago, have maybe a 1 in 1,000 chance of being an ancestor of anyone alive today. That's how drastically the population was reduced. That's how close humanity came to extinction. And this is a fact that should make you shiver, because it means that all of human civilization, all of the people who have ever lived, all of the people who are alive right now, all of the people who will ever be born in the future, are descendants of a tiny handful of people who somehow managed to survive the most catastrophic environmental event in human history. And those survivors were changed by it. Genetically, they were changed because they were the only people who had the traits necessary to survive. Maybe they had better ability to digest different foods. Maybe they had metabolisms that were more efficient. Maybe they had psychological traits that made them more resilient to extreme stress and loss. Maybe they were lucky. But whatever it was, those survivors passed those traits on to their children, and their children passed them on to their children, and eventually, after 10,000 generations, those traits ended up in you, in me, in everyone alive today. And as this catastrophe is unfolding, as humans are dying and migrating and struggling to find food, the world is changing in other ways too. The ocean currents are being disrupted by the cooling, which means that the supply of fish and sea creatures that some human populations depend on is affected too, and the weather patterns are changing. Monsoonal rains that might have fallen regularly are being disrupted by the presence of all this ash in the atmosphere, which means that the rivers that people depend on for water are becoming unpredictable. Some might dry up while others are flooding, and there's probably dust storms and ashfalls. And the day-night cycle is disrupted because the ash is so thick that even during the day, it's dark enough that you might need fire to see during what should be daytime, which means that people are using more fire, more fuel, and fuel is becoming scarce because plants are dying. And this creates this vicious cycle where everything is getting worse and worse, and the world that these humans thought was stable, the world that their grandparents knew, and their great-grandparents knew, and their ancestors knew for hundreds of generations, is gone. It's been replaced by something alien and hostile, something that doesn't want humans to survive, and survival becomes not about thriving, not about art and culture and spiritual practice, but about the bare minimum, about finding the next meal, about keeping your family alive for one more day, and many families don't make it. Many lineages end. Many groups of humans simply disappear from the historical and genetic record. And this is a silence that we hear echoing through time, the silence of all the humans who didn't survive, all the knowledge that was lost, all the languages that went extinct, all the stories that were never told again because there was no one alive to tell them. And then it hits. The pyroclastic flows, those rivers of superheated gas and rock moving at 400 miles per hour, they race outward from the caldera like an invisible tsunami, and anything in their path simply ceases to exist. Forests incinerated in seconds. Any living creature caught in that path turn to ash before their nervous system even has time to register pain. And behind those flows come the tsunamis, massive walls of water triggered by the sudden displacement of the ocean floor crashing into the coasts of the Indian Ocean with apocalyptic force, destroying everything from the shoreline inland for miles and miles. But the pyroclastic flows and the tsunamis, as devastating as they are, they're only the beginning, because what's happening in the sky above Sumatra is something far worse, far more consequential for the fate of humanity. The ash column rises and rises, spreading outward in all directions, carried by the winds, and within days, ash begins to fall across all of South Asia, and we're not talking about a light dusting here. We're talking about ash so thick in some places that it buries entire forests. In India, depending on where you are, the ashfall ranges from 6 inches to 15 feet. Entire villages buried under volcanic dust. The sky above southern India, which should be blue and sunny, turns into this terrible grey-brown murk, like twilight at noon, and then it gets darker, and this ash layer, this physical evidence of Toba's fury, archaeologists have found it. It's buried in the geological record, it's there in the earth for anyone to see, and it becomes one of the most important dating markers in human history, a timestamp pressed into the very earth itself, a moment when the sky fell and changed everything, and if you were alive, if you were somehow in that region when the ash started falling, you'd see it coming. A wall of grey on the horizon, growing larger and darker, blocking out the sun, and then the ash would start. First just particles floating on the wind, then heavier, thicker, coating your skin, filling your mouth, choking the air, making it hard to breathe, and you'd see the animals panicking, birds fleeing in confusion because the sun is disappearing in the middle of the day and the temperature is dropping. Because here's the thing about a supervolcanic eruption. The ash itself is one problem, but the real killer is what else is in the atmosphere. Billions of tons of sulfur dioxide rising into the stratosphere where it never falls back down, never gets washed out by rain, just stays there, high above the clouds, forming a haze, a veil that blocks out the sun's light and heat. And this is volcanic winter. This is the real apocalypse. This is where the story of humanity could have ended. And over the next weeks and months, the global temperature begins to drop, not just by a degree or two, but by 5 to 15 degrees Celsius. And to put that in perspective, during the last ice age, the global temperature was only about 4 to 7 degrees colder than it is today, and that ice age covered much of North America and Europe in sheets of ice miles thick, glaciers that stretch down from the Arctic, and so a drop of 5 to 15 degrees is utterly catastrophic. It's incomprehensible. It's the kind of climate shift that breaks civilization, breaks ecosystems, breaks the delicate balance that life depends on. And in a world where humans are already living on the absolute margin, where every calorie counts, where a bad hunting season can mean starvation, where a failed harvest can wipe out an entire band in a single winter, this volcanic winter is an extinction-level event, because now summer doesn't come, or if it does come, it's brief and cold. The snow and ice that would normally melt in spring keeps piling up. The glaciers that exist in mountainous regions start advancing again, spreading down the valleys like slow-moving rivers of ice, and the photosynthesis that powers the entire food chain, that takes the sun's energy and turns it into plant matter, that feeds animals that feed humans, that process slows down to a crawl. Plants don't grow like they should, the seeds don't germinate, the fruits don't ripen, and the grasses that fed the herds begin to disappear, and the herds themselves start to die, and across Africa, where most of humanity was concentrated at this time, the experience is like living in an extended twilight, or perhaps a permanent overcast day, except it gets worse and worse, the darkness deepens, and if you were there, if you were part of one of those small bands of humans eking out an existence on the African continent, you'd wake up one morning and notice the light was wrong. The sun seemed dimmer somehow, dimmer in a way that doesn't make sense, and the air was hazy even though there were no clouds, and days pass and weeks, and the sun doesn't get brighter. If anything, it gets dimmer and it gets colder. The kind of cold that seeps into your bones, and the sky starts to look strange. This brownish-grey tinge that shouldn't be there. This discoloration that makes you uneasy. And then you realise what's happening. The sky itself is falling, the air is becoming toxic, and the ash that's travelled all the way from Sumatra. Yes, some of it makes it across the Indian Ocean, across Asia, and eventually it reaches Africa. Not as thick as it is in India, but enough to make a difference. Enough to darken the sky. Enough to make the air taste wrong when you breathe it. A metallic taste, like licking copper. And what was gradual becomes acute, because as the ash and sulfur dioxide settle into the atmosphere, they begin to form sulfuric acid, acid rain. And when rain falls, it's no longer neutral water, it's acidic. It burns your skin slightly, it stings when it hits your face, it kills the plants faster, it poisons the water sources, and you're drinking water that tastes metallic and wrong, and your skin breaks out in lesions, small burns from the acid rain, and the animals you hunt are disappearing. The megafauna that used to roam the plains in vast herds are starving as their food sources disappear. The fish in the rivers are dying, unable to tolerate the acidic water, their gills burning, the birds are fleeing, migrating south in search of a sun that hasn't disappeared, and the plants are withering, the grass is turning brown and dying, the forests retreating, and the temperatures continue to drop, and you're sitting around a fire at night, huddled close because the cold is intense, the kind of cold that doesn't make sense in this latitude, the kind of cold that kills, and you're wondering what's happening. Your ancestors never taught you stories about a time like this, because there's never been a time like this, not in human history, not in the oral traditions that stretch back generations. This is something utterly unprecedented, something that breaks the pattern of seasons and weather that humans have learned to navigate. And the desperation starts to set in, because winter is lasting too long, summer never really comes, and the food stores you've prepared are running out, and there's no way to replenish them because nothing grows, nothing hunts the way it used to, and you watch the children grow thin, their ribs showing through their skin, their eyes growing larger in their faces as they waste away. And the old people die first because they don't have the reserves, their bodies simply shutting down from starvation and cold, and then the teenagers and then even the strong adults start to waste away, and you're making decisions you never thought you'd have to make. Decisions about who eats and who doesn't, because the food is simply running out, and the hunting expeditions that go out take longer and longer and come back with less and less. Maybe a single small animal when they used to bring back enough meat to feed the band for days, and some of them don't come back at all, the hunters disappearing into the volcanic murk and never returning, because people are desperate, people are starving, and desperate starving humans are dangerous, and you've heard stories from travelers about wars breaking out over hunting grounds, about cannibalism, about tribes that simply vanished because they couldn't adapt, about entire populations that just gave up and let themselves die. And you're wondering if your band is next, if these are your final months, your final years, if this is the end of everything that your family has built over countless generations. And around this time, human populations across the world begin to crash. The genetic evidence is clear. There's a severe bottleneck in human genetic diversity that happens at this time period, and the numbers tell an astonishing story. Before the eruption, there were probably around 50,000 to 100,000 humans on the planet, maybe more, spread across Africa, some scattered populations in the Middle East and Southern Europe, and then, in the generations following the Toba eruption, that number drops, and it drops dramatically, and the estimates vary depending on which geneticist you ask. Some researchers suggest the global human population dropped to as few as 3,000 breeding adults. Some go as high as 10,000. But the low end, the most conservative genetic estimates, suggest that the number of breeding pairs might have been as low as 1,000 to 2,000. Think about that. 1,000 to 2,000 breeding pairs. That's the entire human species bottled down to the size of a small village. A few hundred families scattered across an entire continent. Every human alive today, every one of us, is descended from people who survived this event. We carry the genetic evidence of this catastrophe in our DNA. There are genetic markers, specific mutations that show up in populations and don't show up in others, and these markers, when you trace them backward through the generations, they all seem to trace back to this moment, to this eruption, this bottleneck, this near-extinction, and what that means is that huge portions of the human genetic diversity that existed before Toba simply vanished. Entire bloodlines disappeared, entire populations in certain regions completely went extinct, and if you were alive during this time, you would have experienced it as loneliness and loss, on a scale that's almost impossible to comprehend. You'd wake up and look around at the empty landscape, and you'd realise that the other bands that used to come through this area, the ones you traded with, the ones your young men tried to find wives in, the ones your grandmother told stories about, they're gone. Not just this year, but year after year, and you'd encounter abandoned camps, old fire pits overgrown with deadened vegetation, bones scattered where people died, skeletons picked clean by whatever scavengers were still alive, and sometimes you'd find them before they became bones. Find people wandering alone, the sole survivors of their bands still alive but completely broken, unable to process what happened to their families, their minds shattered by starvation and grief, and you'd have to decide whether to take them in, feed them with your own scarce resources, share your dwindling food stores with them, or leave them to die. And many bands made the choice to just keep moving, to focus on their own survival, because charity, kindness, compassion, these are luxuries you can't afford when you're starving, when every bite of food might be the difference between life and death. And so people were left behind, abandoned, and they died alone, and their death meant the death of their entire bloodline, their entire genetic legacy, just erased from history, generations of stories and knowledge and skills just vanishing into nothing. And it happened again and again across the African continent, in the Middle East, in every corner of the world where humans were struggling to survive. The human population was collapsing, bands were going extinct, entire tribes disappearing from the face of the earth, and the survivors were scattered, isolated, unable to maintain genetic contact with other populations, because travel became impossible when you're starving, when the world is colder than it's ever been, when the roads are choked with ash and the weather is deadly, and communication between distant populations broke down, and for generations, maybe decades, maybe a century or more, humanity was fragmented, broken into isolated pockets, small groups struggling to survive in the darkness, and in those isolated pockets humanity continued to hang on by its fingernails, continued to survive through sheer willpower and determination, and the genetic evidence shows this starkly, because when you look at the DNA of all humans alive today, when you examine the genetic code that makes us who we are, you see a pattern that says we all passed through a moment of extreme vulnerability, a moment when we came very close to ending, a moment when the number of our ancestors was reduced to almost nothing, and the story of human survival is, in many ways, the story of what happened in those dark years after the Toba eruption, when a small, desperate group of humans scattered across the African continent and beyond somehow found the strength to endure, somehow found ways to maintain their humanity and their connection to each other, despite the fact that the world was falling apart around them. and they passed on to their children the ability to survive, the genetic and cultural knowledge that would eventually allow human populations to recover and expand and spread across the entire planet. And all of that hinges on the fact that somehow, despite everything, despite the volcanic winter and the ash and the acid rain and the starvation and the desperation and the death, humans didn't go extinct. We made it through. We survived one of the closest calls in the history of our species, and that survival is written into every cell of our bodies. And now let's understand what this bottleneck actually meant for human genetics. Because the numbers are even more striking when you really think about them. When the global human population drops from maybe 100,000 people to maybe 3,000, you're losing genetic diversity at an astonishing rate. And in small populations, something called genetic drift starts to happen, where random mutations, things that don't help you survive and don't hurt you, they just randomly become more common or less common because of chance, because there aren't enough people to maintain genetic stability. And this means that the survivors of the Toba eruption, they didn't just survive by chance, but any genetic traits they happened to carry, those traits got amplified in the surviving population. So if one group happened to have certain genes for height or skin color or metabolism, those genes would become more common simply because that group survived. And this is why when you look at modern human populations, you see patterns of genetic similarity that suggest all humans descended from a very small founding population at this time, and this also means that for the people living through the eruption, for the humans who were actually there in Africa and elsewhere watching the world collapse, they didn't know that they were the ancestors of all future humanity. They didn't know that their children and their children's children would inherit the world and rebuild civilization and eventually land on the moon. They just knew that they were starving, that their families were dying, that the sky had turned grey and cold, and they had to keep moving, had to keep hunting, had to keep trying to find food and shelter and warmth. And they did this day after day, week after week, month after month, and then year after year, and slowly, ever so slowly, the ash began to settle out of the atmosphere. The sulfuric acid aerosols began to fall as rain, the temperatures began to rise, and after maybe 6 to 10 years of volcanic winter, the sun started to get brighter again, and the world started to slowly warm, and the plants began to grow again, and the animals began to return, and the humans who had survived began to slowly expand again, to move into new territories, to make contact with other surviving groups, and to rebuild the genetic networks that had been shattered by the eruption. But during those dark years, the years when the sun didn't shine, something changed in the human genetic code, something that's still visible today if you know where to look, and that something is the story of how close we came to ending, of how fragile human civilization actually is, of how dependent we are on the sun and on the stability of the climate, and on the food chains that support us. And when you look at the world today and you see climate change happening, you see the ice melting and the weather becoming more extreme, you might think of those people who survived the Toba eruption, the ones who lived through a time when the climate changed so dramatically and so quickly that it nearly wiped out the entire human species. And you might wonder what they would think if they could see us now, if they could see the descendants of their children spreading across the entire planet, building cities and civilizations and technologies, and you might also wonder what they would think if they knew that we were changing the climate again, that we were doing to the atmosphere what the volcano did 74,000 years ago. But this time we were doing it intentionally, even if we weren't meaning to, and this time we had the intelligence and the knowledge to understand what was happening and the ability to stop it, but we were choosing not to, and the survivors of Toba, they probably wouldn't have understood that choice, because they had fought so hard to survive the volcanic winter that they would have given anything to have stable weather and reliable food sources, and here we are with those things, and we're gambling with them anyway, and the genetic evidence of the Toba eruption is like a warning written into our DNA, a message from our ancestors saying that we are not as permanent as we think we are, that a single catastrophic event can reduce an entire species to the edge of extinction, and that the only thing standing between us and oblivion is luck, and the strength and determination of the survivors, and maybe, just maybe, the willingness of humans to keep going even when everything seems hopeless. And let's think about what those survivors actually experienced, because we can piece together the story from the geological record and from what we know about human populations at the time. Imagine being a woman in East Africa, maybe around what is today Ethiopia or Kenya, and you're living with a band of maybe 30 or 50 people, your extended family, and you've known this group your entire life, and for generations before you, this same group has lived in this same region, And then one day the sky starts to change, and at first it's subtle, just a dimming of the light, just a slight chill in the air that doesn't make sense. And your hunters go out and they come back with less food than usual, and everyone notices, but no one quite knows why. And then the ash starts to fall, just a fine dust at first, but it keeps falling, day after day, week after week, and the sky gets darker and darker, and the temperature drops, and the plants start to wilt, and you realize that something is very wrong, something fundamental has changed, and as the months pass, the stores of grain and nuts that your people had gathered in preparation for the dry season begin to run out, and the hunting gets harder and harder because the animals are starving too, and some of them are dying, and the ones that are still alive are moving away, migrating to places with better resources, and you follow them. You have to follow them, because if you stay in one place where there's no food, you will die. And so your band begins to move, and they reach out to other groups, trying to find food, trying to trade, trying to find shelter, and some of those groups welcome you, and some of them turn you away. And as the years pass, you see people dying, you see your children getting thin, you see your mother deciding not to eat so that her children and grandchildren can have more, and you see your brother leave to go hunt and he doesn't come back, and you don't know if he starved to death somewhere in the dark, or if he was killed by another band desperate for food, or if he just gave up and lay down to sleep and never woke up, and you keep surviving, you keep living, you keep going, because that's what humans do. We survive, we persist, we endure, and eventually the sun comes back. Slowly at first, just a brightening in the sky over weeks and months, and the temperatures rise and the plants come back and the animals come back and life begins to recover, and you realize that you made it, that you're one of the lucky ones, that you survived the apocalypse, that you're still alive and you have children, and those children have children, and those children have children, and 500 generations later, those descendants spread across the entire world, and you're one of them. You, the reader of this script, you, the listener of this story, you are descended from the survivors of the Toba eruption. You carry in your genetic code the markers of that bottleneck. You inherit the genes of those who had the strength and the luck to survive. And so, in a very real sense, your existence is improbable. It's a miracle, because there were so many moments when your ancestors could have died, so many chances for them to be wiped out, and if any one of them had died before they had children, you wouldn't exist. And the fact that you do exist is because of an unbroken chain of survival stretching back 74,000 years to those dark days after Toba, and that chain includes people who shared food when they were starving, people who helped strangers when they had nothing, people who kept moving forward even when it seemed pointless, people who fought to survive not just for themselves but for the future, for their children and their children's children, for us. And this is the story written in our DNA. This is the message from our ancestors. This is what the bottleneck means. It means we're all connected, we're all family. We all share a common origin point in the African savanna, in the darkest days of the volcanic winter. And when you think about that, when you really let that sink in, it changes how you see the world. It changes how you see other people, because we are all related. We all descended from the same small group of survivors. We all carry the genes of those who endured the unendurable. And this is why the Toba eruption matters, why it's not just a historical curiosity or a distant scientific fact, but something that speaks directly to who we are as humans. And every time you look in the mirror, you're looking at the descendant of someone who survived the worst catastrophe that the Earth threw at humanity. And every time you think about the future, you should remember that your ancestors faced something much worse, and they kept going. And that genetic memory, that inheritance of resilience and determination, it's in you too. It's been passed down through countless generations. And so when the world feels overwhelming, when things seem dark and difficult, you can think of those survivors 74,000 years ago, standing in the ash and the cold and the darkness, not knowing if they would live to see another sunrise, not knowing if their children would survive, but keeping going anyway. And you can draw strength from that because you are their child, you are their legacy. And the fact that you exist proves that humanity can survive almost anything. So imagine you're standing on a coastline somewhere in southern Africa, maybe 75,000 years ago, and everything has gone quiet. And that's the only thing that might save your life. The world has changed so completely that if you looked inland toward the interior, you'd see a landscape of ash and darkness, of plants withering and dying, of a food chain that's been snapped at every link. But here, on the coast, something strange and precious is happening. The ocean continues to be the ocean. The tides still come in and out. The shellfish still cling to the rocks, waiting, offering their gifts to anyone with the strength to gather them and smash them open. And there are people here, small groups of them, who have made a desperate choice to stay close to the water because they've figured out what would save them. When the inland world failed, the coastal world kept working. Imagine being one of those early survivors, waking up in a cave that overlooks the Atlantic or the Indian Ocean, your stomach empty but not empty enough to kill you today. You can see the shellfish in the tidal pools. You can wade in and gather them, crack them open with a stone, eat the soft meat inside. It's not much, but it's reliable. It's there every day. The mountains inland are gone, buried in volcanic fallout, choked with ash, hostile in ways that human beings had never encountered before. But the ocean is indifferent to what happens on land. The ocean is still the ocean, and you're going to survive because you had the good fortune, or maybe the skill, or maybe just the stubbornness to be living near the water when the world ended. Scientists have found the evidence of this in places like Pinnacle Point in South Africa, a cluster of caves that overlook the Indian Ocean, caves that were continuously occupied by humans throughout the Toba period and after. What they found there tells an extraordinary story. In the archaeological layers dating to around 74,000 years ago, right when Toba would have hit, there are massive accumulations of shellfish remains. Middens, archaeologists call them, piles of shells left behind by human gatherers. And here's what's remarkable. While the rest of the world was falling apart, while species were dying and populations were collapsing, these people at Pinnacle Point just kept eating shellfish. They kept living. They kept gathering, kept hunting small animals, kept doing the things that humans do to survive. The shells tell a story of continuity. And that continuity might be the whole story of human survival. Think about that for a moment. For the entire archaeological record at Pinnacle Point during the Toba period, you see the same pattern of shellfish gathering, the same tool types, the same evidence of fire use. These people didn't move, they didn't migrate. They stayed put right there on the coast, eating what the ocean provided, and they survived. And the people who survived, the ones who didn't starve, who didn't freeze, who didn't breathe in too much ash and develop the kind of lung infections that would have killed them slowly in those dark caves of Europe. Many of them may have been coastal populations. Many of them may have been in Africa. Many of them may have been exactly like the people at Pinnacle Point. Because here's the thing about population bottlenecks. They don't affect everyone equally. The catastrophe is global, but the impact is local. Populations that had access to reliable food sources, food that didn't depend on plants that need sunlight, food that didn't depend on large game animals that needed vegetation, food that came from the ocean, those populations had an advantage, a tremendous advantage. Coastal populations had access to a food source that was largely independent of what happened on land, while inland populations were starving, watching their hunting grounds turn to ash. Coastal populations were eating. While people in temperate regions were dying of cold and hunger, people near the equator or in coastal areas with more moderate climates were surviving. The coasts became refugia, islands of life in a dying world. The mathematics of survival during a global catastrophe aren't complicated. You need food, you need shelter, you need a climate that won't kill you in your sleep. The coasts provided all three. The oceans provided food that existed independently of what was happening on land. The caves provided shelter, and many coastal regions, particularly in Africa and around the Indian Ocean, provided climates that were tolerable, even if the sky was dark and the temperature had dropped. So it's entirely possible, even likely, that the genetic ancestors of all living humans today are disproportionately descended from coastal populations. That the people who survived Toba were not evenly distributed around the world, but concentrated in places where the ocean could save you. And if that's true, then we're all children of the coast. We're all descended from people who learned that shellfish could save your life when everything else failed. We're all descended from people who stayed close to the water when the world ended. The shellfish didn't get ash in them the way the land food did. The shellfish filtered the water, sure, but they continued to filter it and continued to provide sustenance. A human being standing in the tide could find hundreds of them, thousands if they spent the day gathering. They could crack them open and eat the protein. They could dry the meat. They could preserve it in ways that gave them a buffer against tomorrow's hunger. The ocean kept producing fish, though in smaller numbers. The ocean kept producing seals and other marine mammals, though these were harder to hunt. But the point is that the food chain of the coast wasn't completely shattered the way the inland food chain was. It was disrupted, yes. It was weakened, certainly, but it kept going. And that's all it took. That's all it ever takes. Just enough to survive one more day after that, one more day after that, until the worst passes, until the sun comes back, until the world begins to heal. Now let's talk about the genetic evidence, and I want you to understand why this matters, why the DNA inside your cells right now tells a story about a near-extinction event that happened 74,000 years ago. Because your DNA is your history. It's a record written in a language that doesn't lie. And the record is strange. It's so strange that when geneticists first discovered it, they couldn't quite believe it. If you took two chimpanzees from the same forest, the same region, maybe living only a few kilometers apart, and you compared their DNA, you would find that they differ from each other more than any two humans on Earth differ from each other. Think about that. 8 billion humans spread across the entire planet, living in every climate, in every continent, speaking thousands of languages, practicing thousands of religions, with skin colors ranging from very pale to very dark. And yet any two humans, picked at random from anywhere on Earth, have less genetic diversity between them than two chimpanzees living in the same forest. That's bizarre. That's not what you'd expect from a species that's been successful in expanding. That's what you'd expect from a species that went through a terrifying bottleneck that was reduced to such a small population that all the genetic variation got squeezed out. And here's where the timeline matters. When geneticists map out when human genetic diversity collapsed, when they look at the mutations and try to work backward to figure out when the human population was smallest, they get a date. And that date is somewhere between 75,000 and 70,000 years ago. It matches Toba. It matches the Supervolcano. It matches the catastrophe that threw the world into darkness. The genetic record is saying the same thing the archaeological record is saying. Something happened. Something terrible. Something that nearly wiped out the human species, and it happened right when Toba erupted. Now, I want to explain how scientists know this, because it's genuinely clever, and it's genuinely amazing, and it shows you the power of modern genetics to read history from the molecules in your cells. There's something called mitochondrial DNA. Your mitochondria are tiny structures inside almost every cell in your body. They're like little power plants, converting the food you eat into energy that your cells can use. And each mitochondrion has its own DNA, separate from the DNA in your cell nucleus. And here's the important part. Mitochondrial DNA is inherited only from your mother. When you were conceived, your mother's egg cell contributed mitochondria to you. Your father's sperm did not. The mitochondria in your cells came from your mother, and her mitochondria came from her mother, and so on back through time, back through the maternal line, back through the generations, back and back and back. Now, because mitochondrial DNA is inherited only through the maternal line, you can use it to trace maternal ancestry. You can look at mutations that have accumulated in mitochondrial DNA and work backward, like branches on a tree, to find a common maternal ancestor. And when geneticists did this, when they looked at the mitochondrial DNA of people all around the world and traced it backward, they found something extraordinary. All living humans, every man, every woman, every child on Earth right now, all of our mitochondrial DNA traces back to a single woman who lived somewhere around 150,000 to 200,000 years ago. Geneticists call her mitochondrial Eve. She wasn't the first woman, and she wasn't the only woman alive at the time, but she was the ancestor of all living humans through the maternal line. Every other woman alive at her time either had no daughters, or had daughters who had no daughters, and so on, until the line died out. Only her line continued, only the mitochondria she carried made it to the present day. Now here's where it gets really interesting. If you look at the mitochondrial DNA of modern humans, and you trace how mutations have accumulated, the rate at which the genetic tree branches out is not constant. It accelerates and decelerates. And there are periods where the tree is very sparse, where there are very few branches, suggesting that the population was very small. Think of it like a family tree, where normally you'd expect to see many branches, many different lineages, many different paths leading from the ancestors in the past to the present day. But in the period around 70,000 years ago, the family tree of humanity suddenly has far fewer branches. It narrows down. It funnels through a tight point. And when you map these sparse periods onto a timeline, when you calculate backwards from the mutations you see today to estimate when those mutations first appeared. You find them clustered around the time of the Toba eruption. The genetic data is saying that the human population went through a severe bottleneck at exactly the time we'd expect from the supervolcano. It's the kind of evidence that would be compelling in a court of law. Multiple independent lines of inquiry, all pointing to the same conclusion, all converging on the same date. The volcanic record says Toba erupted 74,000 years ago. The genetic record says the human population bottleneck happened around 70,000 years ago. The difference could be measurement error. The difference could be the time it took for the effects to fully cascade through the population. But the match is unmistakably close. Too close to be coincidence. The same pattern shows up in Y chromosomal DNA. The Y chromosome is what makes males male. It's the chromosome that only males carry, that only fathers pass to sons, similar to how mitochondrial DNA is inherited from mother to child. And when geneticists trace Y chromosome lineages backward through time, when they look at the mutations that have accumulated on the Y chromosome and work backward to find a common male ancestor, they find something remarkable. All living humans, every man on Earth right now, all of our Y chromosomes trace back to a single male ancestor, whom they call Y chromosomal Adam. He wasn't the only man alive at his time, but he was the only man whose sons had sons who had sons all the way down to the present day. Every other man's lineage died out. Every other Y chromosome was lost. Only his line continued. And just like mitochondrial Eve, Y chromosomal Adam's lineage shows signs of a severe population bottleneck around 70,000 years ago. The male lineage contracted. The number of men reproducing and passing on their Y chromosomes dropped dramatically. The genetic tree of male ancestry narrows at the same point in time as the female ancestry narrows. It's too much of a coincidence to be anything other than a real event, a real catastrophe that affected both males and females at the same time. The bottleneck shows up in both the maternal line and the paternal line. It shows up in nuclear DNA, the DNA in the nucleus of your cells that you inherit from both parents. It shows up in the mutation rates, in the genetic diversity, in every way that geneticists can measure it. The evidence all points to the same conclusion. Something happened around 70,000 to 75,000 years ago that reduced the human population to a fraction of what it had been before. And the timing is no coincidence. The timing matches Toba. The timing matches the catastrophe. Now, I want to emphasize something here because it's important and it's often misunderstood. The genetic evidence suggests that the global human population was reduced to perhaps 10,000 to 30,000 individuals at the minimum. Some studies suggest it could have been even smaller, but this wasn't the only breeding population left on Earth. There were still populations scattered across the world, in Africa, in Asia, maybe in the Mediterranean region, maybe in other places where we haven't yet found the archaeological evidence. These populations were separated from each other. They couldn't breed with each other. They evolved separately, but they all went through a genetic bottleneck. They all experienced population collapse. They all nearly died out. And over the next few thousand years, as the climate began to recover and the volcanic winter began to fade, these populations began to recover as well. They began to expand. They began to migrate, and they eventually recolonized the world. But even with all that expansion, even with all that recovery, the genetic diversity that had been lost in the bottleneck was never fully restored. We're still living in the shadow of Toba. We're still carrying in our DNA the mark of that near-extinction event. We're still a genetically homogeneous species in a way that's unusual for a large mammal, and it's because of what happened 74,000 years ago. Now here's something that's equally sobering. Toba didn't just affect humans. The supervolcano left its genetic fingerprints on other species as well. Chimpanzee populations in Africa show evidence of a population bottleneck at the same time as the human bottleneck. When geneticists studied chimp DNA, they found the same strange pattern, the same sparseness in the genetic tree, the same evidence of a population collapse. Gorilla populations show the same thing. The genetic diversity of modern gorillas is lower than you'd expect from a species that was continuously abundant. Something happened 70,000 years ago that reduced the gorilla population. Orangutan populations in Southeast Asia were hit especially hard. Their genetic diversity collapsed, and they've never fully recovered. It's as if the entire world of great apes experienced the same catastrophe, the same population collapse, the same brush with extinction. The great apes were all affected by Toba, all of them. And when you look at other mammals, Especially in Southeast Asia, the region closest to Toba, the devastation was even more severe. Entire species went extinct. The megafauna of Southeast Asia, the large animals that had dominated the landscape for millions of years, many of them vanished in the aftermath of Toba. The volcanic ash that fell on Southeast Asia was so thick, the climate disruption was so severe, that the entire ecosystem collapsed. Large animals that depended on abundant vegetation starved. Predators that depended on large prey starved. Species that had survived for millions of years blinked out in a geological instant. And in the parts of Southeast Asia that weren't directly affected by the ashfall, the climate change was still catastrophic. The Indian subcontinent was choked with volcanic ash. Vegetation died. The monsoon patterns that bring rain to that region were disrupted. Drought swept across the land. Forests that had stood for thousands of years withered and died. And the animals that depended on those forests, the animals that had evolved in that specific ecosystem, they couldn't adapt quickly enough. They couldn't find enough food. They starved. They went extinct. The fauna of Southeast Asia after Toba was fundamentally different from the fauna before. It's as if a line had been drawn across evolutionary history, and the world on one side of that line was completely transformed. And here's what's particularly striking. The species that survived Toba were often the species that were small, or that could feed on a wide variety of foods, or that had short reproductive cycles, or that had other characteristics that allowed them to adapt quickly to rapid environmental change. The species that went extinct were often the large species, the specialists, the ones that depended on a specific type of food or a specific type of habitat. And that pattern, where a catastrophe selects for certain characteristics and against others, that's exactly what you'd predict from an extinction event. Toba acted like a filter, letting some species through and crushing others. And that filter shaped the world we live in today. The animals that exist on Earth right now are the descendants of the animals that could survive Toba. And the humans that exist on Earth right now are the descendants of the humans who survived Toba. We're all shaped by what happened 74,000 years ago. We're all shaped by the supervolcano. Think about what this means for you. When geneticists trace the Y chromosome lineage backward, they're not just looking at patterns. They're reading a story written in your body, a story about your ancestors and theirs going back through time. And that story has gaps. There are periods where the lineage thins out, where there are fewer branches, fewer variations, suggesting fewer males reproducing and passing on their DNA. And when you calculate when those gaps occurred, when you work backward from the present day and estimate the time when the population was at its smallest, you get a number. And that number is around 70,000 years ago. Give or take a few thousand years, but remarkably close. Remarkably unmistakably close to the Toba eruption. Your DNA knows what happened. Your body carries the memory of Toba in every cell. The same is true of the mitochondrial lineage. The same is true of the nuclear DNA. The same signal shows up over and over again in different ways, using different methods, in different populations across the world. It all points to the same conclusion. The human species went through a genetic bottleneck. It all points to Toba, and when a population goes through a bottleneck, it doesn't just become smaller. It also becomes less diverse. It loses genetic variation, and that lost variation can sometimes be permanently gone. If a particular genetic variant was present in only one or two individuals before the bottleneck, and those individuals didn't survive, then that variant is gone from the species forever. The genetic diversity that the species loses during a bottleneck is like an extinction of information. It's like burning books from a library. The library survives, the knowledge survives in general, but specific unique books are lost forever, and that's what happened to the human species during Toba. We lost variants, we lost genetic diversity, we became a more homogeneous species, and while our populations have expanded since then, while we've spread across the world and multiplied into billions, we've never fully restored that lost diversity. We're still, in a genetic sense, a population that's recovering from a near-extinction event. We're still carrying the scars. We're still marked by what Toba did to us. We're still defined by the genetic bottleneck. And here's the last piece of this puzzle, the thing that brings it all together. The fact that all living humans share such a recent common ancestor, the fact that our genetic diversity is so low compared to other great apes, it doesn't mean that Toba reduced humanity to a handful of individuals. It means that Toba reduced humanity to a number small enough that our genetic lineages all converge at a recent point in time. Maybe there were still tens of thousands of humans alive after Toba. Maybe there were still different populations scattered across the globe, but they were isolated enough, or the catastrophe was severe enough, that the genetic variations didn't survive in all of them. The variations didn't spread. The lineages didn't branch as much as they would have in a larger, more connected population. So when we measure the genetic diversity of modern humans, when we see how little variation there is compared to other great apes, we're seeing the ghost of Toba. We're seeing the signature of a population that was reduced, separated, isolated, and brought to the brink of extinction. And we're also seeing something else, the signature of our own resilience. Because we survived. Against impossible odds, against a supervolcano that threw the world into darkness and cold, against a catastrophe that killed most of the other large mammals on the planet, humanity survived. Some of us survived. A small number, a genetic bottleneck. But we survived. And from that small number came all 8 billion of us alive today. Think about what that means. You are here because of a coastal population that made a choice to stay near the ocean. You are here because a woman decided to wade into the tide and gather shellfish. You are here because a group of humans looked at a world that had ended and found a way to keep going anyway. You are here because of decisions made in desperation, because of knowledge about where to find food when the world was starving, because of the sheer stubborn will to survive when survival seemed impossible. You are the genetic heir of the Toba survivors, and that's not just poetry. That's biology. That's what the DNA evidence is telling us. The genetic record is saying that your lineage can be traced back to a group of humans who lived through the worst catastrophe our species has ever endured. And they lived through it. And they passed on their genes. And now you're here, reading about them, learning about what they survived. You're thinking about their struggles 74,000 years ago, and you exist because of their choices. The Toba eruption was the worst thing that ever happened to humanity. But it wasn't the end of humanity. It was the end of one world and the beginning of another. It was the catastrophe that would define our species, that would shape our genetic legacy forever. And we should remember that when we think about catastrophe and survival, when we think about the resilience of the human species, when we think about what it means to be human, we're all carrying the memory of Toba in our cells. Every cell in your body contains the echo of that volcanic winter. Imagine standing at the edge of a world reborn. It's been 15, maybe 20 years since the last ash fell from the sky, since the sun disappeared behind that veil of grey. The volcanic winter is ending. The temperatures are finally rising. The plants are returning. Small shrubs first, then grasses, then trees beginning to creep back across the scarred landscape. And you are one of the few, one of perhaps 2,000 humans who walked through that apocalypse and lived to see this moment. This is what it means to be a Toba survivor. This is where our story takes its strangest turn. Because what happened next wasn't slow. It wasn't gradual. It was an explosion. A burst of human expansion so rapid, so deliberate, so successful that it rewrote the entire map of human civilization and possibly our very genetics. Let me take you into the recovery phase, those critical centuries after the volcanic winter, when the world was still poisoned, still hostile, still a place of death and danger, but also a place of opportunity for those who had learned how to survive the unsurvivable. The ash is settling. The volcanic aerosols are slowly falling from the atmosphere. Sunlight is returning degree by degree, month by month, year by year. The oceans are warming again. The ice is retreating. The surviving bands of Toba humans are emerging from their caves, their shelters, their desperate hiding places. They're moving cautiously, because nothing is certain yet. The world is still cold. The growing season is still short. Food is still scarce. But it's better than it was. It's better than the years of darkness and death. It's better than the horror of watching your family members starve or freeze or sicken with diseases born from the ash and the stress and the malnutrition. And here's something crucial that scientists have begun to understand in recent decades. The survivors weren't just lucky. They were selected. Not by nature in the way we normally think of natural selection, not through predators or disease or simple random chance. They were selected by the most brutal test imaginable. They were the ones with the knowledge to survive when the world ended. They were the ones with the social bonds tight enough to keep communities together during apocalyptic stress. They were the ones smart enough and flexible enough and creative enough to adapt to conditions that had never existed before. They were the ones willing to take risks, to try new foods, to experiment with new techniques when old methods failed. They were, in a very real sense, the best of us, the smartest, the most resourceful, the most connected, the most innovative. And in the tens of thousands of years that followed, as populations recovered and humans began to move and expand and colonize new lands, that selection advantage compounded. It multiplied. It created a positive feedback loop that accelerated human progress. Because unlike the hundreds of thousands of humans who died in the Toba event, the weak and the strong who were simply in the wrong place, the unlucky and the ill-fated, the young and the old who couldn't survive that specific catastrophe, the survivors carried genes that had proven themselves in the most extreme conditions on Earth. They had genetic variants related to stress response, to quick thinking under pressure, to brain plasticity and learning ability, to the capacity to cooperate under unimaginable strain. When they had children, those children inherited not just genes but also knowledge and cultural practices that had been proven in the fires of global catastrophe. They inherited stories and skills and wisdom about how to survive the unsurvivable. They inherited a genetic and cultural legacy forged in the worst crisis humanity had ever faced. This is what scientists call a genetic bottleneck with a selection advantage, and the results were extraordinary. Within 1,000 years of Toba, populations were growing again. The death toll had slowed. Births were beginning to exceed deaths. Childhood mortality was still high, but not as catastrophic as it had been. Within 2,000 years, humans were beginning to explore beyond their original territories. Small groups were pushing into regions they had never occupied before. Within 5,000 years, they were moving steadily outward, establishing new settlements, new territories, new ways of living adapted to each new environment. And within 10 to 20,000 years after the eruption, something that seemed impossible was happening. Humans who were genetically descended from those 2,000 survivors were spreading across the entire planet. They were doing something that no human population had managed before. They were leaving Africa. They were colonizing the world. Now let me be clear about what this means. For 300,000 years before Toba, humans had existed in Africa and the immediate vicinity. There were excursions into the Middle East, maybe into southern Asia, but nothing permanent, nothing that stuck. The human species had a home, and that home was Africa. There were attempts to expand, certainly, but they failed. Populations that migrated out of Africa apparently couldn't sustain themselves. They died out. They returned. They failed to establish permanent settlements in new lands. But after Toba, that changed completely. The world's populations might have been devastated, but they had learned something crucial. They could survive anywhere if they were clever enough, if they were adaptable enough, if they were willing to take risks and try new things and modify their strategies when something didn't work. And so the Great Expansion began. It was the beginning of humanity's conquest of the planet. Picture yourself as part of a small band of perhaps 50 humans living in northeastern Africa, maybe around the Horn of Africa or the Red Sea coast, perhaps 80,000 years ago. You're not aware that you're part of a historical moment. You're just trying to survive, trying to feed your family, trying to navigate a world that's still recovering from catastrophe. But your group is growing. Your children are healthy. Your hunting parties are successful more often than not. The knowledge you inherited from your ancestors, the survivors, is serving you well. And there's pressure building, population pressure. Not everyone can stay in the same territory. Resources are finite, game is limited, competition for hunting grounds is increasing, tensions are rising, and so the decision is made. Some of the younger people, the risk-takers, the adventurous ones, the ones who are restless with the thought of exploring, they're going to move on. They're going to follow the coast. They're going to explore. And they're going to make a choice that will echo through every moment of human history that follows. They head toward the Red Sea, or they push south along the African coast. They're moving along the shoreline, which makes sense because coastlines are highways in a world without roads, without vehicles, without any technology beyond what you can carry. There's food there. Shellfish, fish, seals, birds, eggs. There's fresh water from rivers and streams. The path is clear and relatively easy to follow. The ocean is a guide, a constant presence, an indicator of direction. And so they walk. Month after month, year after year, generation after generation, these small bands of humans are moving eastward. They're carrying with them the knowledge of how to survive on coasts, how to make tools, how to navigate by landmarks and stars and the behavior of animals. They're moving into territories they've never seen, where the plants and animals are unfamiliar, where the climate is different, where everything is new and strange and potentially dangerous. But they've already survived the worst. They've already been through the Toba event. They've already learned what it means to adapt or die. They've inherited the genes and the knowledge and the cultural practices that got their ancestors through apocalypse. So they keep going. Driven by curiosity, driven by necessity, driven by the deep human urge to explore and discover and settle new lands. They reach the Sinai Peninsula. Now the Middle East opens up before them. The climate is harsh but not impossible. The desert is vast, but there are oases, there are rivers, there are resources, there are opportunities for those clever enough and brave enough to exploit them. Some bands stay, others keep moving. They're spreading like a wave across the southern edge of Asia, a wave of human consciousness expanding into new territory. They're moving through what is now southern Pakistan, following the coasts, moving inland when necessary, always testing new environments and learning what works and what doesn't. Some of them might push north into what is now the Levant, into what will eventually become the birthplace of agricultural civilization. But most of them keep following the coast, following the line between land and water, following the abundance of the shoreline. They reach what is now Saudi Arabia, still scarred in places by Toba ash, still recovering from the catastrophe, still marked by the eruption's massive impact on the landscape and climate. They push into what is now the Arabian Peninsula, and then, and this is crucial, they reach India. India, which was buried under a meters-thick layer of ash just a few thousand years before their arrival. The landscape is transformed. The soil is poisoned with volcanic material. The ecosystem is still reeling. The forests haven't fully recovered. The animals are still adapting. But the humans who arrive there aren't afraid. They've seen worse. They've lived through the thing that killed millions, and so they settle. They spread. They adapt to the Indian landscape. They learn which plants are edible, which animals are dangerous, how to navigate rivers and monsoons and tropical forests. They establish settlements. They establish trade routes. They establish communities. And then they keep going. Some of them push inland. Others, the more adventurous ones, the ones who have tasted the freedom of exploration, the ones who have realized that the world is much larger than anyone had imagined. They keep following the coastline. They move into Southeast Asia. They spread through the Indonesian archipelago, hopping from island to island, adapting to island living, becoming seafarers as well as hunters and gatherers. They establish themselves in Java, in Borneo, in Sumatra, the very region where the volcano that nearly destroyed them erupted. And here's where the story becomes almost incomprehensibly brave. At some point, perhaps 70,000 years ago, perhaps a bit later, a small band of these humans, descendants of Toba survivors, makes a decision that changes everything. They look out at the ocean. Between them and the next landmass there is open water. There's no land bridge. There's no obvious connection. There's just ocean and distance and uncertainty and danger. And they decide to cross it. We don't know exactly how. They might have used simple rafts made from logs and vines and reeds, lashed together with plant fibers or sinew. They might have paddled with makeshift oars. They might have drifted on currents, blown by winds they didn't understand, hoping they would find land before their supplies ran out. They might have navigated by stars and bird behavior, using knowledge inherited from their ancestors who survived catastrophe. But somehow, miraculously, they made it to Australia. 65,000 years ago, humans were setting foot on a continent that had never seen a human footprint before. They were crossing open ocean. They were doing something that shouldn't have been possible for people with Stone Age technology. But it happened. Because these weren't just any humans. These were the descendants of people who had survived the worst catastrophe in human history. They knew how to adapt. They knew how to take risks. They knew how to persist in the face of overwhelming odds. They knew how to think creatively, how to solve problems, how to survive situations that would have killed ordinary people. And Australia wouldn't be the last frontier they conquered. As the centuries and millennia rolled on, as populations continued to grow and expand, as the climate warmed and stabilized into something resembling the modern world, these same descendants would eventually make their way to Europe. They would arrive in a continent that was beginning to cool again as the next ice age approached, and they would flourish. They would create art. They would create culture. They would create the first stirrings of everything we recognize as human civilization. They would paint cave walls with ochre and charcoal, creating images of animals and hands and symbols. They would make flutes out of bone and ivory. They would create jewelry and beads and evidence of trade networks spanning hundreds of kilometers. And some of them would eventually make one more impossible journey. They would cross the frozen waters of what is now the Bering Strait. Or perhaps they would voyage along the coast of North America, island hopping like their ancestors did in Southeast Asia, and they would discover the Americas. Two continents that had been untouched by human presence for hundreds of thousands of years would be colonized by humans within just a few thousand years of the Toba eruption. The entire world would be filled with humans. Every continent except Antarctica would bear human footprints. But here's where the story gets even stranger, even more profound. Because there's something else that was happening during this expansion, something that's written not in the archaeological record, but in our DNA and in our behavior and in the artifacts we left behind. Around the same time that humans were beginning this global expansion, sometime between 50 and 70,000 years ago, suspiciously close to the post-Toba period, there was an explosion of something that had never existed before in quite the same way. Symbolic thinking, complex culture, art, music, trade networks, ritual and religion. This is what scientists call the Upper Paleolithic Revolution, or the Human Revolution, depending on who you ask and what part of the world you're looking at. It's the moment when human behavior changed fundamentally. Before this period, human tools were relatively simple and functional. They were effective, sure, but they didn't change much from one generation to the next. Humans were tool makers, but they weren't particularly creative about it. The same stone hand axe design persisted for hundreds of thousands of years. But then, suddenly, at least in evolutionary terms, everything changes. Humans begin making sophisticated tools with multiple parts. They make bone tools and ivory tools, not just stone. They make jewelry. They make beads from shells and ostrich eggs. They make figurines of animals and what might be female forms, suggesting fertility rituals. They create art. In caves across Europe, humans are painting animals and abstract symbols on walls with pigments and brushes made from plant materials. They're creating handprints by pressing their palms against the stone and blowing pigment around them, leaving their personal mark on history. In South Africa, humans are making tools with such sophistication that they suggest planning several steps ahead, an innovation, and the ability to imagine an object that doesn't yet exist and create it. Humans are trading objects across vast distances, suggesting the existence of complex trade networks and the ability to communicate value and desire. Humans are creating burial sites with grave goods, objects buried with the dead, suggesting beliefs about death and the afterlife, suggesting that humans were thinking about abstract concepts like the soul, or the afterlife, or the continuation of existence beyond death. Humans are making flutes out of bone, suggesting music and the desire to create beauty for its own sake. It's like someone switched on a light in the human brain, and suddenly everything was possible. Language became more complex. Abstract thinking became more common. The ability to teach and learn cultural knowledge became more efficient. It's the birth of the modern human mind. Now, here's the hypothesis that some scientists are beginning to explore, and it's a provocative one. What if the Toba bottleneck actually triggered this revolution? What if the intense survival pressure, the near-extinction event, the selection for the smartest, most cooperative, most innovative humans actually accelerated human evolution in a way that led directly to this explosion of culture and behavior? Think about it. You're living in a world that's been devastated by a supervolcano. Most humans are dead. Resources are impossibly scarce. Cooperation isn't just nice, it's essential for survival. The groups that survive are the ones where individuals can work together effectively, where they can coordinate complex tasks, where they can communicate ideas and knowledge from person to person, and from generation to generation, and across the passing years. The survival of the group depends not just on physical strength or hunting ability, but on intelligence, creativity, problem-solving ability, the capacity to teach and learn, the ability to think in the long term and plan for future challenges. And so, naturally, over generations, the people who are best at these things, the smartest, the most cooperative, the most creative, the ones with the biggest brains and the most flexible thinking, are the ones more likely to survive and have children and pass their genes to the next generation. Their genes spread through the surviving population. Their personality types become more common. Their ways of thinking become the default for human consciousness. And then, as populations recover and expand, as humans spread across the world and encounter new environments and new challenges, these traits are carried forward into new territories, new climates, new ways of living, and suddenly you have humans who are not just surviving, they're thriving, they're creating, they're innovating, they're doing things no humans had done before, they're painting on cave walls, they're making music, they're trading, they're creating art. The behavioral revolution might not have been caused by the Toba event directly, but it might have been accelerated, intensified, even enabled by it. The bottleneck reset human genetics and selected for the traits that would define modernity: language ability, theory of mind, the ability to understand that other people have beliefs and desires different from your own, long-term planning, creativity, cooperation, the capacity for abstract thought. This is a hypothesis, mind you. It's not proven. But the coincidence of timing is striking. Toba at 74,000 years ago. The behavioral revolution beginning sometime between 50 and 70,000 years ago. The global expansion of humans beginning around the same time. It's almost as if the Toba event didn't destroy humanity's future. It created it. It forged modern humans in the crucible of near-extinction and changed us fundamentally in the process. And here's another piece of the puzzle that's even more intriguing, even more scientifically fascinating. In recent decades, as DNA sequencing has become faster and cheaper and more sophisticated, as the ability to read the human genome has become almost routine, scientists have begun to discover something remarkable. There are certain genetic mutations that are nearly universal in modern humans, found in 95% or more of all human populations alive today, from Africa to Europe to Asia to the Americas, but which are either absent or extremely rare in pre-Toba human remains, and in our evolutionary cousins like Neanderthals and Denisovans. These aren't mutations that make you look different or change your fundamental capabilities in ways you'd notice. They're subtle mutations, many of them affecting brain development, or the structure of language circuits in the brain or immune function, or the regulation of stress hormones. One of the most famous is in the FOXP2 gene, which is involved in speech and language. Neanderthals had FOXP2, but their version was different from ours. Some scientists think that human-specific versions of FOXP2 and related genes might be related to language ability and the capacity for complex speech, though this is still controversial and not fully understood. But the point is, there are genetic markers that seem to have appeared after Toba and then spread rapidly through the human population, becoming nearly universal in a time frame that would be impossible if the gene was merely neutral. How can this happen? How can a mutation go from being present in one person to being present in the entire human species within a few thousand years? Well, in a small population, genetic drift, random changes in gene frequency due to chance alone, is much more powerful than in a large population. A mutation that appears in one person or in one small group can spread to the entire population much more quickly if the population is small, because there's less genetic diversity to dilute it out. It's like, if you have a 100-person company and one person starts a new trend or comes up with a brilliant idea, it'll spread through the whole company much faster than if you had a 1,000-person company, where the idea might get lost in the noise. The Toba bottleneck created a population that was so small, just a few thousand humans, that new mutations, if they were even slightly beneficial, or if they appeared in someone with high status or many descendants, could spread like wildfire. Within a few thousand years, a mutation that appeared in a single individual could be present in every human on Earth. And perhaps some of those mutations related to brain size, mutations related to the development of language circuits, mutations related to how the immune system functions, mutations related to how the body processes and stores energy, mutations related to how the brain regulates emotion and stress, happen to be slightly beneficial in the environment that post-Toba humans found themselves in. Perhaps they were beneficial for survival, perhaps for reproduction, perhaps for the social cooperation and cognitive flexibility that Toba survivors needed to thrive. And so they spread. They became common, they became universal, and so humanity became not just genetically smaller, but genetically different. Not just survivors of a catastrophe, but products of it, shaped by it in our very DNA, in the code that makes us who we are. If you could somehow meet a human who lived before Toba and a human who lived 50,000 years after Toba, you probably wouldn't see huge differences. You wouldn't think they were different species. You wouldn't assume they couldn't interbreed or communicate. But you might notice something. The post-Toba human might have slightly larger brain volume in certain regions, particularly regions associated with language and social cognition. The post-Toba human might have subtle differences in language ability or social cognition, or the capacity for abstract thought. The post-Toba human might have immune system variations that reflected the pathogenic environment of their post-catastrophe world, variations that protected them against diseases they would encounter. The post-Toba human might process stress differently, with a more resilient stress response system, inherited from ancestors who had survived the unsurvivable. These differences would be subtle, but they would be real, and they would all trace back in some way to the genetic reshuffling that happened in that tiny population of survivors huddled in caves and shelters across Africa, struggling to survive when the world had ended. This is the hidden narrative of Toba. It's not just a story about extinction and survival, it's a story about transformation. It's a story about how catastrophe can change a species. The 74,000-year-old eruption didn't just nearly destroy humanity. It nearly destroyed humanity and then remade it. It selected for the traits that define us. It reset our genetic clock. It created the conditions under which modern human culture could flourish. The humans who spread across the world in the tens of thousands of years after Toba weren't just the lucky survivors. They were products of the most intense selection pressure that our species has ever experienced. They were the smartest, the most cooperative, the most innovative, the most resilient, and they carried that legacy with them to every corner of the earth. So as you imagine yourself in that post-Toba world, standing at the threshold of humanity's greatest expansion, standing at the edge of that recovered landscape, looking toward distant horizons you cannot see but can imagine, understand that you're not just watching a population recover from a near-extinction event. You're watching a species be forged in fire. You're watching humanity become modern. You're watching the genetic and cultural inheritance of every human alive today take shape. The ash is still falling in some places. The world is still cold. The future is still uncertain and dangerous and full of challenges. But the survivors are stepping out of their shelters. They're looking toward distant horizons. They're building boats. They're making tools. They're teaching their children the knowledge that got them through the darkness, and they're about to change the world forever. But here is where the story becomes complicated, where science stops being a neat narrative with a clear beginning and ending, and becomes instead a web of competing theories, of evidence that points in different directions, of scientists who have spent their entire careers arguing about what really happened in those volcanic years. Not everyone agrees that Toba caused the genetic bottleneck at all. This is the uncomfortable truth that rarely makes it into popular documentaries, the messy reality of how science actually works. Some researchers point to the ash layers found across India, to the fact that beneath these layers of volcanic debris, archaeologists have found stone tools, evidence of human activity, and above the ash layer, more stone tools, more evidence that humans were there before and after. That continuity seems unbroken. The Jwalapuram site in southern India is particularly significant in this debate, containing stone tools both above and below the volcanic ash layer that scientists have dated to around the time of the Toba eruption, suggesting that humans didn't just survive the eruption, they survived it right where they were, adapting, persisting, their toolkit and methods changing, but their presence never wavering. These researchers argue that if the eruption had been as catastrophic as the bottleneck theory suggests, if human populations had been reduced to a few thousand or even a few hundred, surely the archaeological record would show a complete break, a sudden absence of human remains and artifacts, a gap in the timeline that we would find unmistakable. Instead, they say, what we see is adaptation and continuity, humans adjusting to a changing world but never disappearing from it. Others go further and argue that the genetic bottleneck itself may have been real, may have actually happened, but that it had nothing to do with Toba at all. Perhaps they suggest the reduction in human genetic diversity was caused by climate change that occurred independently of the volcano, by periods of extreme cold or drought that occurred at different times in different places, or by human migration patterns and population movements that had their own causes and their own logic. Maybe the bottleneck was caused by disease, by environmental pressures we haven't even identified yet, by the simple mathematics of small populations, that were already isolated from each other, already separate enough that genetic drift alone could account for the patterns we see in our DNA today. The more you study this question, the more you realize how much is still uncertain, how much is still being debated, how many pieces of the puzzle are still missing or hidden beneath layers of sediment and time. The ash from Toba blanketed parts of the Indian subcontinent and Southeast Asia. This part is not disputed, the geological evidence is clear and abundant. But exactly how far did the ash travel? Exactly how much did it cool the planet? For how long did the cooling last? Did it affect all regions equally? These are the questions that still divide scientists, and the answers matter enormously for understanding what happened to human populations. Some models suggest that the volcanic winter lasted for years, creating conditions so cold and so dark that agriculture would have become impossible, that ecosystems would have collapsed, that the carrying capacity of the Earth would have dropped dramatically. Other models suggest the effects were more regional, that the worst impacts were felt in Southeast Asia and perhaps parts of Africa, but that other regions escaped the worst consequences. Other models suggest that the cooling was significant, but not catastrophic, that humans with the right adaptations and the right location could have survived and even thrived if they had the knowledge and the tools. And here is where the Jwalapuram evidence becomes so important, because it suggests that at least some humans did adapt and survive, that they developed new tools or modified old ones, that they changed their diet or their settlement patterns or their hunting strategies, but that they never disappeared. If this is true, if the archaeological record in India shows genuine continuity through the volcanic years, then the bottleneck theory needs to be modified or rethought or rejected entirely. Some researchers have proposed a middle ground position, suggesting that the bottleneck was real but that it wasn't caused solely by Toba, that the volcano may have been one stress among many, that the real danger came from the combination of environmental pressures, that Toba pushed already fragile populations over the edge, but didn't create the edge in the first place. This seems to many researchers like the most honest interpretation of the evidence we have, a position that acknowledges the genetic data and acknowledges the archaeological record, that explains why both are true and why they seem to contradict each other. In this view, the Toba eruption was catastrophic and consequential, but humans were already living on the edge, already fragmented into small populations separated by geography and distance, already vulnerable to exactly the kind of shock that a supervolcano could deliver. The volcanic winter may have killed many humans, may have forced others to migrate, may have broken apart social networks and family groups that had existed for thousands of years, but it didn't necessarily reduce humanity to a few thousand survivors huddled in caves. Instead, it was one of many crises that humans faced and survived, one of the selection pressures that shaped our species, one of the reasons we are genetically less diverse than our ancestors. This is a less dramatic story than the near-extinction narrative, less cinematically compelling perhaps, less the kind of thing that makes for great documentary moments. But it may be closer to the truth, and in science, the truth is always more important than the drama. And yet, even with all this uncertainty, even with all this debate, there is one thing that nearly all scientists agree on, one thing that the evidence supports clearly and consistently. Whatever happened 74,000 years ago, it mattered. The genetic bottleneck is real, the loss of diversity is real, whether it was caused by Toba alone or by Toba in combination with other factors, or by factors entirely unrelated to the volcano. Something happened that reduced human genetic diversity, that left populations smaller and more genetically similar than they had been before. And this reduction in diversity has echoed through the entire subsequent history of our species, has influenced our susceptibility to disease, has constrained our genetic potential, has made us all, in some sense, children of survivors, inheritors of a genetic legacy shaped by crisis and catastrophe. So let us accept the scientific consensus on this point, while remaining honest about what we don't yet know, while acknowledging the ongoing debate about the causes and the extent of the bottleneck. Let us say that something catastrophic happened around 74,000 years ago, that human populations were reduced and tested in ways that we are still trying to understand fully, and that our species survived that test, that our ancestors found ways to adapt and persist and ultimately flourish. Now let us turn our attention away from the ancient past, and look instead at the present moment, at the reality of supervolcanoes in the modern world, at the possibility that what happened 74,000 years ago could happen again, and at what such an event would mean for our civilization, for our species, for the 8 billion humans who are alive right now. Because Toba did not die in that eruption. The volcano is still there, still active, still capable of eruption. The massive caldera that collapsed during the eruption is now filled with water, creating Lake Toba in northern Sumatra, the largest volcanic lake in the entire world. A body of water so immense that it contains more water than all the Great Lakes of North America combined. The lake itself is strikingly beautiful, ringed by steep volcanic walls, dotted with islands, deep blue and serene and peaceful in appearance. But beneath that peaceful surface, the magma chambers are still active, the heat's still building, the geological forces that drive supervolcanic eruptions still at work. Toba could erupt again. Geologists cannot say when, cannot predict the exact timing, but they are confident that it could happen, that the conditions for another eruption exist deep beneath that beautiful lake, and Toba is not alone. There are other supervolcanoes on our planet, other locations where the same geological conditions exist, where the same catastrophic potential lies waiting. Yellowstone in Wyoming is perhaps the most famous, a supervolcano that erupted catastrophically multiple times in the distant past, that still shows signs of volcanic activity, that still has geysers and hot springs and underground temperatures that would be impossible in a non-volcanic region. The magma chamber beneath Yellowstone is monitored constantly by scientists who are watching for any signs that another eruption might be coming. Campi Flegrei in Italy, near Naples, is another supervolcano, one that has erupted within the last 5,000 years and that shows signs of ongoing unrest, of magma chambers moving and pressurizing, of ground deformation that suggests forces are at work beneath the surface. Taupo in New Zealand is another, a caldera filled with a lake not unlike Toba, showing signs of ongoing volcanic activity, capable of the kind of eruption that could devastate the region and affect the world. And there are others, scattered across the planet, dormant perhaps but not dead, waiting with the patience of geological processes, waiting for the pressure to build, waiting for the moment when they might erupt again. Now imagine this. Imagine that tomorrow or next week or next year, one of these supervolcanoes erupts. Imagine the ash column rising 30 kilometers into the atmosphere, spreading out in all directions, turning day into darkness, blocking out the sun across entire continents. Imagine the ash falling, coating the ground, clogging the atmosphere, creating what scientists call a volcanic winter, a period of global cooling that could last for years or even decades. We know something about what this would mean because scientists have studied the effects of past eruptions, and because they have created computer models of what a modern supervolcano eruption would look like. And the picture they paint is genuinely terrifying. Within weeks of a major eruption, temperatures across the planet would drop by an average of perhaps 10 degrees Celsius, more in some regions, less in others, but everywhere cold beyond anything recorded in modern history. Snow would fall in the summer in places where snow never falls, ice would form on the seas, growing seasons would be cut short or disappear entirely, crops would fail. Within a year, global food production could drop by 70 or 80%. Stored grain reserves might last for a few months, perhaps to the end of that first terrible year, but after that hunger would spread, starvation would become endemic, civilizations would begin to collapse. With 8 billion people alive today, with almost the entire human population dependent on global agriculture, with supply chains that are stretched and fragile and vulnerable to disruption, a supervolcanic eruption would trigger a catastrophe beyond anything in recorded human history. There would be no aid from other regions because all regions would be affected. There would be no importing of food from distant countries because those countries would be struggling with the same crop failures. The political order would disintegrate. Governments would fall. Wars would begin as people fought over the remaining food. Diseases would spread as malnutrition weakened immune systems and sanitation broke down. Billions of people would die, perhaps not immediately, perhaps not all at once, but inexorably, as the cascade of consequences unfolded. It is difficult to imagine, difficult to hold in your mind the scale of such a catastrophe. We live in an age of technological sophistication and global abundance where food is cheap and plentiful, where we have grown accustomed to the idea that we can provide for everyone, that starvation and famine are diseases of the past, relics of history. A supervolcanic eruption would shatter all of that, would strip away the veneer of civilization, would leave us dependent once again on luck and location and the ability to survive on almost nothing, just as our ancestors were 74,000 years ago. But there is something else, something that may give us hope. There is the fact that humans survived Toba, that we adapted, that we found ways to persist even when the world was hostile and the future was uncertain. We survived because we are resourceful, because we are adaptable, because we have the capacity to innovate and change and find solutions to problems that seem impossible. If a supervolcano erupted today, some humans would die, undoubtedly, perhaps billions of them, but others would survive. Some populations would find refuge, places where the effects were less severe, where crops could still be grown, where the cold and darkness were not as extreme. Others would develop new technologies or modify old ones, would learn to farm underground or to grow crops under artificial light, would find ways to preserve and store food, would slowly rebuild civilization in the ashes of the old one. We have the knowledge and the tools to respond to such a crisis in ways that our ancestors did not. We have the understanding of agriculture and nutrition, and medicine and engineering that could help us survive. We also have the knowledge of the danger, the understanding that such a thing is possible, which means we could potentially develop strategies to prepare for it, to store food, to create seed banks and genetic repositories, to develop backup plans and contingency strategies. Whether we actually do this, whether we actually prepare for the possibility of a supervolcanic eruption, is a different question, a political and economic and social question rather than a scientific one. But the knowledge exists, the possibility exists, even if we currently choose not to prepare for it. So as we think about Toba, as we contemplate the bottleneck, as we imagine our ancestors struggling to survive in the volcanic winter, we might also contemplate our own vulnerability, our own dependence on systems that could be disrupted, our own need to remain adaptable and prepared. We are not as far removed from our ancestors as we might like to think. We are still vulnerable. We are still dependent on the cooperation of millions of people, on supply chains and infrastructure that could be disrupted, on ecosystems that could collapse. And we still have, somewhere deep in our DNA, the capacity that they had, the ability to survive crises and to adapt to impossible conditions. It is a sobering thought, but perhaps not an entirely discouraging one. Perhaps it is a reminder of our own strength, our own resilience, our own capacity to persist in the face of catastrophe. And now, as we prepare to close this story, as we bring this long journey through time back to the present moment, back to you and me and the 8 billion others alive right now, let us contemplate what it means to be a survivor, to be the inheritor of survival, to be part of a species that has endured catastrophe after catastrophe and lived to tell the tale. Every single person alive today, all 8 billion of us, we are the direct descendants of that tiny group of humans who survived the Toba eruption and the volcanic winter that followed. Even if the bottleneck was not as severe as some have suggested, even if not all human populations were reduced to a few thousand, even if some groups continued on in relative isolation, still the fact remains that we are all connected to those survivors, all part of the same human family, all carrying in our bodies and our minds and our very genes the legacy of their survival. Every language that is spoken today, every single one, can be traced back to the languages spoken by those survivors, to the sounds that came from their mouths as they communicated with each other, as they passed down stories and knowledge and wisdom. Every religion that exists today, every belief system, every spiritual tradition, all of them ultimately derive from the sense of meaning and purpose and connection that our ancestors created in order to make sense of their world, to survive their crises, to bind themselves together into communities. Every civilization that has ever existed, from the ancient Egyptians to the modern nation-states, all of them are built on foundations laid by those early survivors, on the social structures and hierarchies and systems of organization that they developed as they struggled to survive and to thrive. Every war that has ever been fought, every battle, every conflict, all of them are disputes between the descendants of survivors, battles over territory and resources and ideas, but ultimately battles between people who share a common ancestor, who carry in their blood the same genetic legacy. Every love story that has ever been told, every romance, every pair of humans who found each other and bound their lives together, all of those moments are echoes of the first human pairs who looked at each other across a smoky campfire in Africa 74,000 years ago and recognized in each other the possibility of connection, the potential for creating something new, for building a family, for creating the next generation of survivors. Every piece of music ever written, every song, every symphony, every melody that has ever moved a human heart, all of it derives ultimately from the capacity for emotion and expression and creativity that those ancient survivors possessed, that they passed down to their children and their children's children, that lives in us still today. Every book ever written, every story ever told, every poem ever composed, all of it comes from the same impulse that moved our ancestors to sit around fires and tell stories, to make meaning out of experience, to transform the raw material of life into something beautiful and memorable and worth sharing. Every scientific discovery, every technological innovation, every piece of knowledge that humanity has accumulated, all of it represents the same drive that kept our ancestors alive. The drive to understand the world, to solve problems, to find better ways of doing things. All of it connects back to those 2,000 or 10,000 or 50,000 survivors huddled on the coast of Africa, eating shellfish and waiting for the sky to clear, holding on to each other and to hope in the face of an incomprehensible catastrophe. They did not know they were saving the future. They did not know that their children's children's children would build civilizations and write symphonies and create mathematics and explore the stars. They only knew that they needed to survive the next day, to find food, to stay warm, to keep their loved ones alive. They made it through somehow, and because they made it through, because they refused to disappear even when everything in the world was trying to kill them, we are here. I am here. You are here. We exist because they existed, because they survived, because they passed on not just their genes, but their resilience, their adaptability, their capacity to find meaning and beauty and connection even in the midst of catastrophe. And so we carry them with us, always, whether we know it or not, whether we acknowledge it or not. They are in our DNA, yes, but they are also in our choices, in our creativity, in our relationships, in our ability to love and to dream and to hope. When you look at the stars tonight, you are looking at the same stars they looked at when the ash finally cleared, when the sky began to brighten again, when they realized that the world would go on, that life would continue, that humanity had survived. When you feel the warmth of a fire, when you feel that primal comfort of flames and heat on a cold night, you are experiencing something that they experienced, that connected humans across 74,000 years with the same basic needs and the same basic comforts. When you sit with someone you love, when you feel that connection to another person, that sense of safety and belonging and continuity, you are experiencing something that they experienced too, that they fought to preserve, that they passed on to you across all those generations. And so, as we come to the end of this story, as we prepare to close this chapter and to step away from the ancient past and back into the present moment, I want to invite you to imagine something. Imagine that you are sitting at a campfire, not in your home, not in the modern world, but in a simpler place, a place where the night is dark and deep, where the stars are bright and numerous, where the fire is the only source of warmth and light. Imagine that you are not alone at this fire. There are others here with you, people you care about, people whose presence brings you comfort. The fire is beginning to burn low now, the flames settling into embers, the heat becoming gentler, more intimate. The night is quiet except for the crackling of wood and the gentle sound of breathing nearby, the sound of other people resting, relaxing, beginning to let go of the day. Above you, the stars are infinite, stretching out into darkness that seems to have no end, stars that ancient humans saw and wondered about, that inspired awe and fear and fascination in human hearts long before we had any way of understanding what they actually were. You are warm now, despite the night. You are safe.